our focus this year is soil, and it's kind of like way over my head, so I just try to make, even though Annie and my wife and I garden, we've gardened for a long time, and she grew up with a heritage of gardening in her family, but it's kind of over my head. And but tonight's topic is degradation.
The downer.
And we're not talking politics here, so this is a safe place. We're talking soil, and our guest tonight is Kim McCracken. And being a native of Western Pennsylvania, I can always detect when somebody's from Western Pennsylvania. Kim grew up in northwestern Pennsylvania, up in Bradford, Pennsylvania, which is kind of like way up there, almost in New York. It's in beautiful country. If you've never been to northwestern Pennsylvania, you want to get there. So, and you're in good company when you're dealing with a person who basically, as a young gal, sold earthworms to anglers. So, so she got started really early, graduated from Allegheny College, which is a really nice little college in Meadville, Pennsylvania. She spent some time in Michigan as a professor and studied at UNH, and after being in Western Pennsylvania and Michigan for a while, decided she wanted to come up to New England, be back in New Hampshire and this region, and who can blame her? So she is the NRCS soil scientist for New Hampshire and Maine, and again, her talk tonight is going to be on soil degradation. I think she's going to go for about a half hour or so. Our format is that you can interrupt anytime you see fit, and I'll try to spot questions for, and I'll try to cover the voids. But I think we're going to go maybe the second half hour or so, just kind of have it open-ended. So you folks who are knowledgeable about these things probably have lots of questions. So I'll turn it over to Kim.
Okay, thank
Welcome.
you. Thanks. So if you can't hear me, just let me know, like raise your hand or something. I have a touch of a cold, so I'm hoping there won't be a coughing fit. But I have water, I'm all prepared. So when Chuck called me and said, we're doing a series on soils, we have 5 topics, I was so excited. And then he said, soil degradation. Like, oh, I get the negative topic. But since I'm a person that can always turn a negative to a positive, I can assure you you're in good hands tonight. And I did pay attention to the series of talks that you're going to have. So I know you've had 2 already, and that you're going to have 2 that largely focus on soil reclamation with an ag focus and soil health. So I'm really going to focus a little bit more on some different stuff so you get a really nice variety in your series. So soil degradation, that's me in the soil pit. It was my best attempt to pose like that I think it's 1952 soil conservation's, it's the Soil Conservation Service photo, but someone else got in the picture. But I do, in fact, love soil. Okay, so since I'm here representing my agency, I do want to talk just a little bit about where I work and what I do. So I work for the Natural Resources Conservation Service. Have any of you worked with NRCS before? Anybody? Chuck, I know you have.
Well, we've worked with the programs.
Right, you've worked with the programs. We're all one big agency. And so we are the lead federal agency for soils. So the Forest Service, they're the lead agency for forestry, and they work primarily on public lands. NRCS, we're the lead agency for soil survey, soil interpretation, soil mapping. As Chuck mentioned, we've sort of grown into doing a lot of other things. Most of the United States is mapped across the country. We're still fine-tuning some areas. The White Mountain National Forest is still undergoing its initial soil survey. But for the most part, soil is mapped, or we have pretty good interpretations. So a lot of our focus in NRCS has been helping, now that we have that information built on soils, we're trying to help people make good decisions about what they do. I'm giving them some advice so they don't make mistakes, and then, once you did that, try to give you some management strategies to turn that around. And that's a lot of what we do. We also work on conservation easements, and I know Lee is a very conservation-minded town. There are a lot of conservation easements in town. And we go out and provide expert advice on soils, wildlife, wetlands, and we work frequently in conjunction with conservation districts and cooperative extension and a variety of other ag service providers. So I know it wouldn't be a soil degradation talk without the Dust Bowl. So Black Sunday, which was basically one of the most intense days of the Dust Bowl, so out in Oklahoma, Texas, just destruction of the sod, the soil wasn't covered, a drought, strong winds, the gorgeous prairie soil blew across the country. And it was a big deal for a very long time. I'm not sure how many of you have watched Ken Burns' series on the Dust Bowl, but it was a very, very big deal that lasted for a very long time. And there are still survivors of the Dust Bowl, and if you ever have an opportunity to talk to someone who was a survivor of the Dust Bowl, the stories are really gut-wrenching. So last year, the International Year of the Soil was the 80th anniversary of Black Sunday. So 80 years ago, and I like to think about the progress that we've made, and we'll talk a little bit about some of that tonight, and I think more the next 2 sessions that you have focusing on soil health and soil reclamation. We'll talk a lot about the practices with agriculture, but I want to draw attention to the photo in the bottom corner. The dust was so severe that it blew to Washington, D.C. And if you know how government works now, government worked the same in many ways back then. When it impacted them directly, something happened. And a lot of that was funding that went to the Soil Conservation Service, which became NRCS. So my agency, my job, my livelihood now stems from soil degradation. So thank you for inviting me to talk about this topic. Okay, so I know that you're all aware that last year was the International Year of the Soil, 2015. We promoted it heavily across the state, the country. Well, one of the things that came from that was a large document on the status of the world's soils. And I figured what a better thing to do than to sit here and read it to you tonight. Right? Okay, so everybody open your handout and we'll read it together. So it's a very large document, and I printed out one chapter. This chapter deals specifically with the regional assessment in North America, so it covers all of the US and Canada. And as such, it's a very broad brush. And just a summary of information from this document for our area, North America and Canada. It's really soil erosion, which is not a surprise in terms of soil degradation, compaction, nutrient imbalances, loss of soil organic matter, loss of soil biodiversity, and that's plants, and it's also microbes, converting land from one use to another, and depending upon why you're converting it and the different uses, you may have different opinions about whether that's positive or negative. And then something that hasn't been a huge issue in New Hampshire really is salinization. We do have some acidification and contamination issues, but with high tunnels, so have many of you seen those? They look sort of like a greenhouse, but with high tunnels, we're finding that we're beginning to get some salinization problems because you don't have that flushing that we get from our normal amount of rainfall. So I won't read the document to you. Okay, so soil degradation, it makes you think that somehow we've ruined the soil. But soil is very resilient. It can bounce back from a number of things, not everything, but many things. But in many cases, what's really happened is we've tried to do something with the soil that it was never intended to do. So it's really a poor match of what we want to do with the soil that's on site. So it's not really bad soil. It is what it is, and it helps to know what you're talking about. Okay. Did I not go down?
Because soil has at the bottom.
Oh, and so this is how I try to explain it to non-soil people. So this slide is for you. So try to think of your soil in a different way, something near and dear to your heart. And since we were talking about the gym earlier, this is very appropriate. I try to think about soil as an athlete. Okay, so think about the wide range of athletes you're aware of, whether it's a bodybuilder, a sumo wrestler, Joni from Maine, a basketball player, a jockey, even a couch potato. That's a sport if you're playing video games. So all of those people have different, maybe genetic abilities. They've trained for different things, and so soil is much the same as athletes. Some athletes are 7 feet tall, some are 4'6". And the 4'6" man or woman trying to be a professional basketball player, it's not impossible. It's highly unlikely. Right? But with the right training, if you're kind of scrappy, you got your good with your hands, with the ball, you could possibly do it. But so think about soil in those terms. There are things that it's very good at doing. Every single soil has things that it's good at doing, but you have to ask yourself, what are you asking it to do? And that's really where we end up with a lot of degradation, because we're asking it to do things it's not prepared to do. Okay, so how does this relate to soil? We talked about that a little bit. So they're not all equal. There's not really a bad soil. We may have made it bad by contaminating it, but a soil that has been undisturbed or uncontaminated isn't necessarily bad. And there are a significant number of things we can do to, enhance a bad soil. So if you know anything about the soil on your property, hopefully you found that out before you bought your property. How many people found out soil information before they bought their property? So I know many of you may have inherited property, so you did some. I know many people who have had grand plans for, grazing, growing corn, doing different things, and it's like, oh, it's all wetlands. Or all those old stone walls that used to be an ag. There's a reason it's not anymore. Okay, so we're going to talk a little bit about trying to match. You have a question?
Where I lived on the roadways here, there was a big open lot that was a farmhouse.
Mm-hmm.
They converted to house lots, but before they did, they came in and stripped off the topsoil and carried it away.
So one of
those new home buyers didn't know what they were in for.
I'm sure. So one of my very first, memories of a soils course that I took was my professor telling me that, way back when they were moving westward in the U.S., after the soil was kind of tired and we were moving to better soil, you would maybe take your kids, but you'd take your soil. You'd put your soil on your wagon and you would drive that with you. That's how important soil was. And I think we're seeing that, but there are regulations in place to try to minimize that, but you still see it all the time. They'll spray on maybe like an inch of manufactured soil that doesn't necessarily, all manufactured soils are not bad, but many of them do not behave like natural soils. Okay, so let's talk briefly about a few soil properties. Have you talked about anything about like texture, bulk density already? Okay, so we'll go over this quickly. There are just 4 things that I want, 4 particular properties, and I'm going to split them into 2 categories. So inherent properties, so the soil is what it is. You can't change it. With our big soil health push in NRCS, I've had a number of people say, can you make my sandy soil loamy? Can you get rid of that marine clay? And the answer is yes, you can, but you're not going to turn the soil that you have into that. You're going to have to remove that and bring something else in. So texture is a key variable, and it's an inherent property. You have what you have, unless you're willing to do a significant amount of work. And then dynamic properties, these are things that we change with our management. They're a little bit easier to change. Some are easier to change than others. In many cases, the change can be a negative trend if you don't know what you're doing. So these are 4 things that we're going to talk about just a little bit today, and they impact a lot of agriculture and construction activities. I could talk for 3 days about soil organic matter, but I'm only going to give you 1 slide because I have no doubt it's been covered quite a bit and it will be covered in the next few sessions. But this, if I had to give you advice about your soil and just told you to do one thing, it'd be find out about your organic matter and make sure it's in the right range. And the right range depends on what you want to do, but organic matter is something that you can change. It can help make a dense soil a little fluffier, and it can help make a pretty sandy soil hold water a little bit better. So this is something that you can do. If you ignore it, so a lot of hay fields or your lawn, if you don't fertilize it and keep that organic matter there, you're basically just mining your soil in a different way. So you're really removing your organic matter. Maybe you're not doing it overnight, but over time, if you're not taking care of your hay field or your lawn, you're really mining your soil. And it impacts just about everything. So the way you manage it impacts the soil health. And I want to talk briefly, but we'll talk a little bit more about it. So with the Dust Bowl, we heard a little bit about air quality. So if your soil ends up in the air, it can be a significant air quality concern. Soil in its place is wonderful. Soil in water, not such a good thing. You know, it can cause a significant amount of sedimentation and contamination issues. And there's a huge link between those, and trying to take care of your soil so that you can grow the crops of interest or livestock is really important. Okay. So who has not seen the textural triangle before? Excellent. I always like to have one person that hasn't seen it. So as soil scientists, we like to have cool little tools to help us, you know, measure things or classify things. I mean, they classify things even smaller. So what this is we try to get at one of the key soil factors, which is really surface area. So the amount of space on the outside of all the little soil particles. And we do it by breaking the pretty small soil particles down into different size classes. So sand, over there is on the bottom, is your most coarse material. Silt is intermediate, and it's along your left. That's right, is that left? Right, my left. And then percent clay. So at the top is your finest soil, so the clay soils. The bottom left-hand side, the sandiest soils. And then silt is intermediate. And then depending upon the triangle where they meet, those 3 percentages, we give it a different texture class. And so it's really trying to get at the amount of surface area in your soil. And it's way more exciting to give textures than to get into the actual surface area in grams per meter squared, cubed. Not something you want to do. I speak from experience. So one of the other master things we said we were going to talk about is bulk density and compaction. And so we talked about soil texture, so those solids. But soil is really, we always think of the solid part, we think of the organic matter, but really the whole of the soil also includes that air space, the pore space. And so that's really half of the soil is mineral. There's a little organic matter, and that's quite variable. I'd say between 1% and 10% in most soils. But that other half is pore space. And so depending upon what's happening, you know, whether it's been irrigated, and like tonight, the surface soil, probably mostly filled with water, not a lot of air. So that's highly variable. And then depending upon the overall texture, or if your soil's been smushed down with a tire tractor or some kind of equipment to put on a house foundation or something, you squeeze out the pore space and you make a very compacted soil. And it's funny, I heard a little bit about compaction, you know, in the last 15 years or so, but really in the last 5 years in New Hampshire, I've heard more talk about compaction as an issue that farmers are facing all up and down, you know, from Coos County down to the Mass border. It's really incredible the impact that that's had, and we're, you know, doing our darndest to find different strategies for different people to make it work. You know, and so not only is compaction, you know, just a general problem of not enough airspace in the soil, but what ends up happening is I want you to look at the picture in the upper left-hand corner. And so this is a fence row, and on the left-hand side, it's a no-till field. And on the right-hand side, it's been in continuous corn, I think, although maybe it looks like soybeans. It's a borrowed photo. But I just want you to get the sense that with residue cover, long-term, not disturbing the soil, just look at the different surface of that soil. You can tell by looking at it that there's water on the surface of the soil on the right-hand side on a regular basis, and you never see standing water on the other side. So what it ends up looking like, and so in the next few months in New Hampshire, as you drive around, you're going to see a lot of, right now the corn isn't growing yet, but you're going to see a lot of standing water on fields. And it's not entirely due to compaction, because we do have a number of marine clays around here, but a lot of it is from driving repeatedly on the soil. And so if it sits there, if the ground is flat, it sits there, it gets decomposes, it smells. But what if you're on a slope? It doesn't go in, but where does it go? Runs downstream, yeah. Oh, what went up? What did it add? It added something, maybe a new arrow. Okay. So this is really, I wanted you to have a visual of soil compaction. So really what we're doing is we're eliminating pore space. So at the top, what you see is you see soil particles surrounded by water, and you have a non-compacted soil and a compacted soil. So it's about the same amount of soil particles, but in a smaller space. So that square, or the rectangle, is smaller in the compacted soil. And then just to give you an idea about how air and water move, in a normal soil, so a non-compacted soil, there's airspace for things to move. And so if it's air or water, what's another thing that likes to move, or a couple other things that like to move through soil that need space? Worms, roots. So if you have a very dense soil, like the soil that we see on the right-hand side, not only does the water likely run off, but the roots aren't getting in, and it's very difficult for organisms to live. And so this is, I guess, another way of looking at it. So these are actual soil photos. So you can get compaction in different places. In this area, due to the glaciers that came across New Hampshire, we have a lot of compacted soil naturally. I mean, think about that, the mile thick of ice driving along, New England. So just that weight alone gives us quite a bit of compacted layers deep in the soil. So we're not necessarily talking about those. Those do have implications for agriculture or for construction, but we're really talking about management derived compaction. So what we see in the top is more of a disc pan, so just like a more shallow disc, but just even though that is much less intensive than some of the other implements that we've used in the past, repeated disking of the soil can cause compaction. And then you see the plow pan below that, which is even more dense. And you can't really see the roots in this photo, so along the right-hand side, if you look very closely, you can see simulated pans, and you can see the roots go down deeper in the low compacted soil. In the soil with medium compaction, they go intermediate, and then with that soil, or the sample on the far right, you don't really see any roots at all, and you can also look at the stunted growth along the top. So it's a nice comparison of compaction. It's not all ag. We have a lot of compaction issues on our forestry land and construction sites. There's a good reason that most of the logging work in New England is done in the winter. How much of you think got done this winter? Without frozen soils, it makes it much more difficult to get out there with that heavy equipment. And a large part of that is that when your soil is wet, you reduce the friction from grain to grain, and so driving over it compacts it much more in wet conditions than other times of the year. So that's why we highly recommend that forestry work happen on frozen soil, because then the soil doesn't compact anywhere near as much. It can still have issues on the surface. But winters like this makes it very difficult for loggers to get out and do their work. And so this is just an example of a site that's been heavily trafficked, and then this photo is a little bit darker, but it's a road that's had a number of ruts in it, and just along the right-hand side is just a huge road cut. So a little more rain, that's going to fall right down into the road. Bad situation. So where's all that soil going to go? Down to the stream. Okay. You ready for the exciting part? Okay. So I didn't put the location or the name of this. Who knows what that is? The Leaning Tower of Pisa. Pizza. Pizza.
That's in Massachusetts.
It's in Massachusetts, yeah, the pizza. So how many of you really think about this as a soil issue? Okay, a few people. It's like, oh, it's really just exciting, someplace I want to go visit. I don't know if I want to go inside, but I want to visit. So I pulled out a bunch of little facts about it. So it's from, 1173 is when they started building it. 5 years later, they already realized that it was starting to lean. And, well, maybe this was not the best location. They did a little soil investigation, and so I wasn't there, just saying. And so this is why I read about it. So basically what they're saying now is that it consisted of sand, a fine sand, clay, and shells, and so really not a strong surface. And when you think about it, look at the tiny footprint of the Leaning Tower of Pisa compared to its height. So they did a number of different things to try to fix it, so you can't really tell visually, but the architects and engineers a few years later tried to make the taller stories a little shorter and kind of tilt it so it would be like a bending Tower of Pisa. Didn't really work, it was still leaning. But they kept building, okay? So by 1372, they had the final 7 floors in the bell tower, and measuring it from when they first put it in, if you look at it now, it's basically leaned 5 meters off perpendicular, so it's about a rate of 2 millimeters per year. They've done a number of things to try to fix it. They've tried to inject some concrete under the base. One of my favorite things, so in the lower corner, they decided to put some counterweights on it. So it's like, oh, if it's leaning that way, let's put a bunch of lead bricks on the other side. And it didn't do anything. So I like to think of this as a really good reason to know more about soil. Okay, so back to compaction. So if anybody wanted to build the Leaning Tower of Pisa today, hopefully they would go to a soil scientist or an engineer for an on-site investigation, and someone would clearly look at the site and say, based on the weight that you want on a given area, this is an unsuitable location. So they would either move it to another place, or they'd have to change the design, bring in new materials. So those are really the options. But so what happens is when you have loose soil, you know, it compacts, but it doesn't necessarily compact evenly, and you get shifting. And from what I've read, there's not a uniform material underneath the Leaning Tower of Pisa. So, you know, maybe part of it's clay, part of it's loose sand. So the clay probably holds up a little bit better unless it's wet and it tilts. So when you put in some kind of foundation, they bring in fill, they compact it down. Okay. I wanted to make this exciting. I knew it's a Monday night, so what can I do to make it a little more exciting? So what I did is I went through the news, and you'd be surprised how many interesting soil stories there are in the news. So I'm going to show you some stories, and then we can talk a little bit about what you see in terms of soil degradation or soil properties. And I may need to read some of the titles to you. I'm not sure how they're going to come out. So up in the top it says, engineers see soil movement under New Orleans levees, and so that's from 2005. So, wow, the soil's moving under the levees. And then a local shot here from just last year, over in Manchester, they had a city salt truck fall into a sinkhole. So what kinds of things might cause these problems? Yeah. So if you have a big water line and that breaks, the soil was not meant to withstand that kind of velocity and being saturated. So what happens when the soil goes, or when the water goes, the soil goes. And then when you get a big vehicle like that, or even the sinkhole on 93, I don't know that I ever heard what that was due to, but probably something similar. The weight on that top, on the surface, goes even though you have the asphalt over it. Soil in the news. Okay, so this was from 2014. Topsoil could be gone in 60 years if degradation continues, and so this is from the United Nations. So this is not necessarily talking about New Hampshire, but the recognition is that in many areas of the world, we are really degrading organic matter at an astounding rate. And so when that organic carbon goes away, where does it go? Goes into the air as carbon dioxide. Where else does it go? So with the erosion that we talked about already, so when the water comes down, and if you're not on a flat surface and there's too much water, it washes right into waters and streams. And you know, having a little bit of soil in a stream may not be such a big deal, but what if your town paid for a huge reservoir and all the local streams are carrying water and sediment to your reservoir? So you've just significantly reduced the life of your reservoir. And also if you have organic matter in your water, you frequently have loss of oxygen due to decomposition in the water, and then like stinky, nasty water. I mean, soil can't be bad, but water can be bad, right? Come on, yeah, it's true. Okay. Okay, so a story from China. So they've done a number of investigations in China because they're really trying to increase the amount of agriculture that they do in China because they have a tremendously growing population. So they've really begun to strengthen their soil programs. They've been doing a lot of soil research and investigations for a number of years, but they've been upping that. And so they're really amazed at the poor state of Chinese soil, so they're out doing some more investigations, surveying whether it's heavy metals, from all the pollution, or just the same thing that we've been doing, growing the same crops over and over again, and that lack of diversity. And this is a shameless plug for the Web Soil Survey. So in the US, we have our own version of a soil survey. So has anybody used a hard copy of a soil survey to find about information about the soil on your property? Yeah, there's not that many Stratford County ones, so I guess that was a bad example.
They had one here, I think.
Okay, I think I still have a few. So we've shifted over to Web Soil Survey, and if you ever want to use it, you can just Google it, Web Soil Survey. And so what we've done is, since we're constantly updating soils information across the country, we put it online so it's always up to date. So all those hard copy ones have great historical information, but they're out of date. And I think the Stratford County one is one of the oldest ones in New Hampshire. And we're hoping to get around to upping, like redoing parts of it, but I think it will be a while. So Web Soil Survey is your best place to go. Okay, so this is something that we hear about more and more. There's a huge emphasis on the seacoast of New Hampshire, throughout New Hampshire, New England, and really all over the place on local foods, growing your own, trying to make sure people in urban areas have access to fresh spinach, tomatoes, all the things that we really take for granted here because we have such a rich ag history here. And so what they're finding is it's really nice to encourage urban gardening, but what do you think they find in some of those soils?
Lead,
Lead? Where's the lead come from?
gasoline,
Gasoline, paint. Anything else they find in those soils? Mercury, arsenic. It really depends on what kind of activities are going on in the local area, but they're finding a lot of those sites may have been old industrial complexes or not too far away, so with the poor air quality regulations we've had in the past, that stuff still resides in the soil. So does that mean that we cannot grow vegetables in huge cities with an industrial history? Okay, so what was one of the options that I talked about already if you have poor soil and you want to do something? You can replace it. So you can bring in new stuff. What they recommend is raised beds. The nice thing about a raised bed is that in a cold area like this, it does warm up a little bit faster. You still want to bring in some mineral soil too, not just all compost. But that's what they've done in a number of places. I worked on a project over in Goffstown where they were having a number of youth work on community gardens, and before we got too far along, we tested the soil and just didn't really think about it that much. And this was like 10 years ago, and we're really surprised just how awful it was. So that project expanded into something else. And so even if you move to a new area, maybe you want to put your garden next to your house, which is never a good idea for sunshine, but if it's the only place you have, and you have an older home with lead paint, I highly recommend that you get it tested, and you can send your soil to UNH and get it tested. Who hasn't heard about this one? Poor soil unearthed at UNH outdoor pool site. I read this and I thought, blame the soil. It's not really poor soil, it's soil, but it doesn't meet their intended purpose. So I have not been on site, although I have been to the outdoor pool. But basically, when they put the old pool in, they just sort of did it without a lot of information. It worked. So could they put the new pool in? Possibly. The issue is they're expanding the Hamel building, so there's going to be even more weight on another side. And they want to make sure that this soil doesn't crack, the concrete, it doesn't run into the river that runs just over here to the left, right? So they got pretty far along, I guess, under the assumption that the old soil was good enough. And living in Durham and working just down the road, this was really an interesting, and being a UNH alum and a soil scientist, you can imagine, I was like following this like you wouldn't believe. It's like, how could they not know to test that? So the good news is they've done the investigations. The pool is supposed to happen sometime late this summer. But the take-home message from this story is what?
Test your soil.
Test your soil. Don't assume that it was good enough for the prior project, it's good enough for your project. Lee made the news. So forward-thinking Lee, unlike putting in the pool, the old mill project, which was basically a gravel pit. There were some organic materials under that. So gravel mining is one of our major types of soil degradation in New Hampshire. We have a lot of glacial materials that have a lot of gravel and sand. So this was an opportunity to build some habitat, have some conservation land. And so I think this was like 10, 12 years ago, maybe more. People in this room highly involved in this project? Is it your project? Okay. But so this is really a success story of a soil that was degraded, but it took a long, long time of survey of what was there. What did you want it to be? So it's like you could turn it into a lot of different things, but there were a lot of meeting and discussions about, okay, this is what it is now, where do we want it to be? And then pulling together that roadmap that we call a conservation plan to get you to the right spot. So bringing in the right materials, grading and shaping the land, doing the plantings, and then folks going out there and now monitoring the incredible wildlife that's out there. So it's really a huge success story. Okay, so we've talked about different types of degradation. We know what happens. So what types of efforts has the US put forth to try to minimize some of this? So this is maybe some of the least exciting stuff, but who's heard of the Food Security Act? Highly erodible land, swamp buster. So basically, we have two things that we call the Food Security Act. So if you want conservation payments or payments for commodities or easement payments from the US Department of Agriculture, you have to agree not to degrade your soil. So, I mean, the programs are voluntary, but if you're going to come to us, you sort of have to play by our rules. So one of the things that we try to make sure is that if you farm lands that are highly erodible, you either don't bring new lands into production. So a lot of the land that has grown back up, we try to avoid those lands. Or new land, you have to have a conservation plan in place. So we have a rotation of corn and hay, or we want cover crops. So we try to work with you based on your goals to make sure that that soil stays covered. And that's really the basic thing. Keep the soil covered as much as possible. And with wetlands, we went through a huge phase for hundreds of years. We have so many areas across the country where we just busted right through all the wetlands. I mean, we cannot go back and undo all of them. I mean, Florida, we can spend centuries trying to restore the Everglades, and we're never going to get back there. But one of the programs through USDA is that we work with folks who want to restore the hydrology in local wetlands and then try to manage them in a specific way so that they can continue to use them in some ways, but that they're not degrading the hydrology and that they're bringing it back so the wet soil is actually wet. So a couple programs that we've had, actually the Old Mill project was one of those conservation easement projects on the bottom. And the other thing that I want to talk a little bit about, and it gets very, how many of you have heard of like important farmland soils, prime soil for easements? So it didn't come about because of easements. The purpose of that program was when federal agencies spend money, we didn't want them to destroy the most productive soils. So really, very forward thinking. So at the national level, we have prime farmland. At the state level, we have soils of statewide importance. And then each county has an opportunity to select a list of soils of local importance. So we have those different levels. And then if there's a federal project that wants to move forward, we have to look at the impact on those designated soils. So we do a number of different things, different layers to try to make sure we're not making things worse. Okay, so let's take a look at Iowa. Iowa's in the news all the time. We spend a lot of money in Iowa trying to improve conservation land, or trying to improve the land, but with years and years of corn soybean rotations, we still find a huge amount of sediment and nutrients going down the river into the Gulf of Mexico, and that's, it doesn't look like we're making progress. So one thing that I just want to point out is there's a huge emphasis, and there's still more of it than I would like. So let's say you have an ag field, so that's a slope over there. On the edge of the water, we highly recommended vegetation. So as the water and the soil moves down the slope, we try to trap it. And so what's the benefit of that? Slows the erosion, traps that soil on the edge. So for water quality, that's really great stuff, right? We like filter strips and buffers. Okay, but if you're the farmer, what are you thinking?
Where's my cropland?
All of my soil has ended up in the filter strip or the buffer. So you'll hear us talking more and more about soil, keep it covered. And you're going to hear about that in the next 2 sessions quite a bit. So anytime you can have a living root in your soil, the soil covered, protected from the rain is a very good thing. And so I always like to mention that example because we talk a lot about buffers and filter strips protecting water, and they do. But if it's your land, you want your soil to stay on your field. Okay, so that's Iowa. So this is Hurricane Irene. So this is the Long Island Sound. So these huge issues are not just happening in the Midwest or in some of the large ag states. So in New England, our Connecticut River Valley is really an incredibly productive area. And so during Hurricane Irene, they had some aerial photos, and you can see all of that wonderful farmland going into Long Island Sound. For a few years, I worked over in Walpole, New Hampshire, so in Cheshire County, southwestern corner. And this is the Vermont side of the river. Not that New Hampshire didn't have many fields that looked the same, but so you can see the river's active, or the stream bank is actively eroding into the river. But honestly, the scariest part is they were growing corn there the year before that, so someone has driven their tractor on that. So there's a huge amount of undercutting on that, and so all of that is going down the river. Okay, so this is a local partnership project. This uses one of the easements that I talked about, so this is another local NRCS project, and I think it's a duplicate of one I've talked about before, so I'll move along. So one of those sites that was protected based on farmland soils was the Governor Dale Preservation Project in Northampton. And so this was a gorgeous site with an ag history that was just about to be converted to 50 house lots. And so the town came together with Southeast Land Trust and then funding from the USDA, and based on those great ag soils, there was this huge partnership to try to make sure those soils would remain friendly to agriculture, even if they're not necessarily tilled all the time right now, or in a garden, or have livestock, but they're still there. Once it's a subdivision, we have the issue with what are they going to do with the topsoil? They're going to take it off site and it's going to go someplace else. So this is a huge success story for us. Okay, who recognizes this general location? It's my freehand drawing of the town of Lee using Web Soil Survey. So I have to admit that I pulled up a map of Lee and I traced it, and then I traced it on my screen. So this is about as low tech as you can get. I think it's pretty close. So one of the things that I talked about was those soil, like the prime farmland soils. So do you see a lot of green on this map of Lee? I was surprised how much, because that's the national designation. So these are the best soils in the nation. And so to have that much in a small town in New Hampshire is incredible. You have very, very good soils in Lee. So if you look at the lighter blue soil, so there's a few of them, not too many. Those are soils of statewide importance. So you have a little bit more, so those are like the next best soils. And then the brighter blue, which sort of comes out gray here, those are the soils of local importance. So really, if you look at a significant part of Lee, it seems like as you move west, your soils maybe aren't quite as productive from an ag perspective. And it's not saying that you can't use them. It's just saying that overall, the best properties are found in those other soils. And so you could easily pull up Web Soil Survey, click the town of Lee or just your property, and then I did bring a flyer about Web Soil Survey so you could step right through and make a map like this of your property. Okay. So we're trying to avoid problems. You want to know your soil, and I just want a reminder that I think will stick with you for a while is when given the choice between being the Leaning Tower of Pisa and the UNH pool, as much as I poked fun at them, they didn't build the pool until they knew what they were doing. So maybe they got far along, but they found out what they were doing. The pool is going in. I'm hoping there aren't problems since I've been talking about it for a while, but they knew what they were doing. Pisa, they probably didn't have the information, but now that the information is readily available, you don't need to be a soil expert. There's information available on Web Soil Survey, and there's also private consultants that you can talk to. But I didn't put stuff on your chair for no reason. So on your chairs, you have the fine 2016 soil planner, AKA calendar. But we like to say planner because we plan to get them out in January, but usually get them out in March or April. And we have different themes every year. I complain every year. It's like, we know when January comes, and they're hearing me on USDA. Please, let's get the planner out on time. So they've had soil health in the past. They've had soil profiles from around the country. This particular one talks about land capability. And so this really gets at the heart of what I was talking about tonight. Matching what you want to do with the capability of the soil. So this is sort of your cheat sheet, and the best soil categories are in the front, and the worst with the most limitations are in the back. So what I did is I took a map of Lee, the same outline, and so as you go from top to bottom, the best soils are red. We don't have that many. And then as you move down to those like light blue, and the trend that I want you to notice is that those blue soils were those poor soils that we talked about before. So this is another way to look at it. So the capability of the soil, there are ratings from class 1 to class 7, and the calendar kind of goes through and talks about what they are. So it's a reference. It's not necessarily a calendar that's going to be outdated. But if nothing else, when you go to look at soils or you look at a Web Soil Survey, start with the capability class. And it will give you an idea about if you have pretty good soil or pretty marginal soil. And it's largely based on slope, texture, is it extra wet? And then this takes it a little step further. And so there's a rating and then there's a sub-rating. So this tells you why it's maybe not the best. So is it prone to erosion? Does it have some kind of soil limitation within the rooting zone? What would that be? Bedrock, stoniness, hard pan, ledge, all of those words we love to say. Excess water. Who knew we'd have that here? So this gives you sort of a nice visual of what you have in Lee. And you can do it site specific. So I like to end on this. I am a dirt doctor, and I like to think I can solve all the problems of the world. And it's nice to be recognized by the Wall Street Journal. They really did recognize that we can solve the deepest problems. And if things aren't going that well in the US or other place on Earth, they are looking for soil scientists in Mars. So I feel like I have great job security, and I really enjoy talking to folks about soil. So thanks for your attention. I do just want to mention that I brought a number of handouts. So this is the International Year of Soil, and I brought some soil health posters. There's also a number of local workshops coming up. So there's the Rockingham County Conservation District has a talk on climate change and ag, and I am the speaker. So shameless self-promotion there again too. And then there's a nice pasture walk coming up. It's a joint effort between Stratford County Conservation District and Rockingham, so those are up there. And then the big event that I plan in New Hampshire hopefully every year, but the last few years, there's a soil conference. And so the first half is a little more general information geared to everyone, and we've partnered with some local soil scientists for, Society of Soil Scientists of Northern New England, SNE, and there's a Southern Soil Science Society of Southern New England, SNE. So don't get them confused. So they have their technical annual meeting in the back later in the afternoon. But if you have any interest in knowing what's going on with different organizations related to soil, whether it's DES, Soak Up the Rain, the Forest Service, Dorn is going to be speaking, so how can you turn that down? You knew you were speaking, right? Okay. And then we have a short session, maybe like an hour and a half, focused on climate change and the change in climate. So Rita Fry from UNH is talking, and we also have a soil scientist coming from Rhode Island who's going to talk about the coastal zone soil survey that we hope to get started. So with that, I am done.
Questions?
Eric?
Kim, could you talk a little bit, you talked about the soil capability map, but could you expand on that and tell people, if anybody's got any current use, about the soil potential index and how that relates to current use taxes, but also that chart of soil capability?
I can do that. So the soil potential index is what New Hampshire uses to assess the value of land based on soil capabilities. And it's very surprising to me the way that it's used. Different people use it. So the same thing with those classifications of prime farmlands, farmland of soil of local importance and statewide importance. So SPI is basically a way to integrate a number of key properties. And so your best ag soils are going to have a 100 for SPI. And then those marginal soils, so those ones that are very wet, they're all bedrock, those will be 0. And so based on the mix of properties from calculations in the mid to late 80s on corn production, they came up with ratings across the state. And so those are used to evaluate your land for taxes. And so at USDA, we just come up with the technical information, the rating, and then how the state and the town uses it. We try to explain it to them, but we're not really behind it. And just a few months ago, I had someone from the Public Utilities Commission and the Planning Commission call me because they wanted all the specs on SPI. I'm like, well, what are you doing it for? Because we want to figure out rental rates to pay towns for utility poles. Because we think they should be in the flat soil that's not rocky, not poorly drained. So all of those areas that you look for prime farmland. And so, you know, it was a good idea, but it is interesting how people take your ideas and use them. And so we do try to visit with the current use board on a regular basis when they have new people and they want to make changes, or just to understand that it's not a perfect system, and if you have people doing different things. And so it's really trying to match that. Rating is based on one thing, but soil value is based on many things, and it depends on the intended use. So, did that help, Eric? Okay.
Other questions?
You said you want to make sure that there's enough organic material in your soil, but you also don't want to have nothing but organic material. What are the drawbacks of having very large amounts of organic material?
So it's not just the amount, you also have to get into the quality. And so the way that I like to describe good organic matter is, close your eyes, think about bananas. Okay, you have very green bananas that no one wants to eat. You have very, very dark bananas that, you know, maybe you make banana bread with them. And then in the middle, you have sort of a range of bananas that most people like to eat. Well, soil organic matter is much the same way. So if you have that fresh decomposed stuff, it's really not good in terms of supporting agricultural, you know, purposes. It's not really releasing plant roots that readily, or nutrients for plant roots to uptake that readily. And if you have very highly decomposed stuff that's been there forever, it's very recalcitrant. It doesn't necessarily give up the good stuff to plants. So there's sort of a quality that you want as well. And it really does depend on what you're growing. One of the main things that I'll recommend to you is that if you're buying something to bring in, like a compost, whether you're making it yourself, get it tested, because an unfinished compost means that it hasn't degraded enough, so it has a lot of nutrients, but it's not ready to release them, and it can actually take nitrogen from your garden. And we look at a carbon to nitrogen ratio. And so, you know, many people have purchased compost. You can have weed seeds in it, you can have contaminants in it. So it is kind of scary. I recommend that you either, you know, buy from a reputable place and ask for the test, or get it tested yourself.
I'm just remembering when you were talking about urban agriculture, you were saying that you wouldn't want just organic material. I assume you mean like sand or something?
If
Is that
you
about
mix
drainage?
it in with sand or loam, so you really want the right mix.
Because of
and-
drainage or for some other reason?
Well, if you only have organic matter, it won't necessarily drain that much, but it helps aerate it more. So if you do, organic matter can compact, but like more coarse soil does also offer benefits for water retention and also holds nutrients. So they hold different nutrients, whether you're talking about cations or anions, so nitrogen, potassium, phosphorus. It's just nice to have variety.
Other questions?
Yeah, I've looked at the maps of the, soils of national importance and state and local, and then look at the land use in Lee, and the best soils are often not in agricultural at this point. And you would normally think that the best soils are the ones that are always going to be stay farming and whatnot. But
Many times those are the first to be developed.
there's a lot of these aren't developed. I think some of the criteria, some of these tend to be some of the heavier soils that are inherently more fertile, but they're more difficult to work.
Absolutely, yeah.
And so this may mean, depending what crop you're growing on it, that they may grow great, but it's hard to work that soil and get that in. And so often what they rank is the best soils for certain conditions but other factors come in on that.
And I think it's also important to recognize that Stratford is one of the oldest soil surveys, and the vision that we had about agriculture and using soil way back then, the 50s and 60s, the concepts have changed quite a bit. And so if we were to go in and change it, we would have a better understanding and recognition of that. But the maps are great. I love the web soil survey, I love the hard copies, but if there's anything that you're actually going to do, put in a foundation, buy a farm, don't rely on a map. Get a soil scientist out there, get an engineer out there, get someone that knows what they're talking about that matches your interests, and do your homework.
Early in your talk, you talked about soil compaction on the increase in New Hampshire.
I don't know if it's on the increase or we just know more about it.
That's what I was going to ask, whether it's just people are reporting more, or whether they're, in your mind, is it because is it just increased activity, there's more agriculture happening, or people are reporting more? Are there other factors? Is there a climate component to that?
So I think we're asking more of each acre. And okay, there are some farmers in here. There are people who like to drive their tractors. And so even though it's possible to combine passes or, maybe not get out there quite as often, there are some issues where liking to drive the tractor. And that is an issue. But anytime you can reduce the number of passes, do multiple things at once, that saves traffic. But without really good information from the past, I don't know the rate of change, if it really is getting worse, but we're doing a significant amount of work to try to change that. And you can do it with cover crops. Some things can be broken up with roots for really bad situations. Even though we're really trying to get people to stop tilling soil, at some point you may actually have to do a deep tillage to rip up that pan, do it once, and then change the way you manage it after that. But just growing a deep tillage radish may not do it, or may not do it at the rate that you want.
There's another.
What is the significance of snow load on compacting the soil?
I would say this year not much.
Last year.
Last year, in general, it's pretty light. I mean, compared to a lot of the other things that we see in terms of traffic. I'm not sure, but my guess would be it's not that significant. Over time, I suppose if we had an extended long winter, maybe like last year, that could be an issue. I would think more that just the trapping of the water, if the soil's frozen, could lead to some anaerobic conditions on the soil surface. So when the soil is frozen, the water doesn't go through it, it'll sit there, and so if you have that soil melting, so it may not be as much compaction, but if you get out there and it looks like the surface isn't frozen, or maybe isn't that wet, and you drive on it, how many people have seen a tractor stuck out in the field? It looks good, but you really have to be careful, and I wish I could remember the exact number. But I think they're saying that a 1-inch rainstorm delays entry onto the average ag field in New Hampshire by a week. So you really have to wait for about a week for that to drain out and get back on it again.
Related question, does freezing and thawing cycles do anything for compaction?
It can. So if we get enough of ice down in the soil profile, there can be some freezing and thawing. We see that quite a bit more on the surface. Usually you don't see it as significantly in New Hampshire down further in the soil profile, but especially, I don't know how many of you have walked out at Adams Point. You walk out there in the winter when it's not that frozen, not that much ice, but you can see ice crystals that are 3 or 4 inches deep. You're out there walking, and the next thing you know, you're like mid-calf up into ice wedges. So it will loosen up the top, but I'm not aware that it does a significant amount of work here to a certain depth.
And it does have a lot to do with Paul's question about climate, because for 2 reasons. One, because of the freezing and thawing cycle. There have been plenty of years when we've had 4 feet of frost on the ground, and that was always the breaking point where you had to put your pipes below 4 feet because you need to get out of frost zone. But that will heave soil, particularly if it's got any clay in it, it'll heave it quite a bit. And unfortunately, in the last 3 or 4 years, we haven't had any frost anymore. So, yeah, I think there's a cumulative effect there where, particularly in heavy clay soils, you do get that gradual compaction. But the other side of the coin is that, for instance, last year, we had practically, at my house, practically 0 rain from the middle of April until the 1st of June. And so there is some compaction just from the reduction of the moisture in the soil too. And then when it does get wet, you don't get that infiltration that you normally would have if there was capillary action all the way up through the soil column. So yeah, there's a big effect of climate.
You have a nice surface crust, and then the water runs off.
Right, and it all runs off. And that's a classic example last year because we had 4 inches of rain on the 6th of June, and it all came down at once. We had rain for 2 months before that, a month and a half before that. So yeah, there was a lot of sheeting and runoff.
And that's one of the big things that we're seeing with climate change. In many cases, the total amount of rain in the year hasn't changed significantly, but we're seeing periods of drought and periods of flood. So instead of more, an even distribution of rain, we're getting those large events and drought, and that makes it much more important for farmers to be resilient, to try to build organic matter, make sure that your soil will allow the water to infiltrate and not run off. You get 6 inches of rain, and if your soil isn't in good condition, you had 6 inches of topsoil.
So here we are, 20 years ago in the Seacoast region, didn't have a very vibrant local food economy. Now we've got a food economy that is established and growing all the time. If anything, we might be short on farmers. We probably have enough land. But what's the balance for you from your perspective when you look at a food economy, a local food economy that is growing, comfortably growing, and maybe exceeding itself? Do you have worries about where we go from here? Where do we go?
I think it's a very exciting time. I think anytime people are more aware about where their food comes from, are excited to know what a seed looks like and the process that it goes along with, I think then it also gives you respect for other food. Mm-hmm. We have a huge problem of food waste across the nation and around the world, so I think it works on that as well. But there's a lot of exciting, scary stuff going on in the world, and we do not have a lot of food security in New England. We don't have that many days of food that we can grow ourselves, and so I see so many benefits of doing that. And one of the things I love the most about my job is that I feel like I can help people who want to be helped and help them make the right decisions. And if they made a wrong decision, I don't judge them. I try to help turn them around and say, okay, what is it that you wanted to? Let's see if we can find a way to do it. And our site visits are free, and you can choose to follow our suggestions or not. If you do want to follow the suggestions, you can compete for funding to install some of the things. But just having that local food available is one of the main emphasis areas of USDA. I mean, look how every small town has a farmer's market now. Back in 2003, I lived in Nottingham. And when I first moved there, I went to the farmer's market. It was a farmer market. There was one person, and that was it. And you go to any of these small farmer's markets now, and I don't think I've been to one with fewer than 8 people. It's very exciting.
Any closing questions?
Coincidental with this series on soil, Reader's Digest this month has an article, The Dark Side of the American Lawn, about lawn chemicals and the downside on the soil and on people's health. So I just found it an interesting coincidence.
Yeah, I
because
read that. Thank you.
I am not a farmer, I am a lawner. Although we do want to garden and we want to grow some fruit trees, and we're one of these very flat, sandy, we grow ant hills kind of properties, so I'm coming here to learn about how can we make our lawn / home garden / forest healthy. Yeah.
Get rid of the lawn.
We're going to get rid of a lot of the lawn.
Is anybody looking at, long-term climate change trends? If, eventually they're going to have to stop growing oranges in Florida and grow them in Connecticut or somewhere. I mean, if crops get shifted as to where they can grow.
So there are several layers of federal government, and many of them, like the Department of Interior, the EPA, they all have their way of addressing climate change. The USDA has a series of, or a bunch of climate hubs, and so they are really areas that they have scientists involved and regular everyday practitioners like me that pull together information to try to provide information that makes sense. You don't want to read the journal article necessarily, you want recommendations for you. And so a few years ago, when they put those out to bid to figure out where they were going to be, Durham, New Hampshire has one. So at the Forest Service, there is the Northeast Climate Hub, and that is the job of a number of folks at the Forest Service, ARS, NRCS, UNH is very involved. And so they're really trying to take all of that information, like a lot of stuff that Cameron Wake works on, a lot of the folks that work on forest ecosystems, and to make recommendations about, should you shift to a different variety? Well, maybe there are some opportunities with the longer growing season. So we're sort of in the infancy, but that's really what we're trying to do. And for my agency, I'm the local contact for that.
But I mean, if, crops like, say, Maine couldn't grow potatoes anymore, or whatever.
They grow different varieties. I mean, I hate to say technology will save us, but I do think there are some ways that we'll be able to adapt, but I think we're going to have to make some changes too. We can't just hope for the best.
So one closing question for you. You're almost like an endangered professional, probably, in the world of
Yes.
the government. So you got 30 people in this room. What can we do to help you? A reminder, the camera's still on, so but talk shop a little bit, and what can we do to kind of help you and help the body of work that needs to happen?
You can talk to the folks at UNH and make sure that we have students prepared for the future. There's no longer a soils department, there's just a few courses, and without an influx of people coming in, there's no work that's going to be done. So that's as simple as that. We need new people.
So thank you very much, Kim.
Thank you.